This video is for Chapter 12, Section 4, Part 2. Chapter 12, Section 4 talks about chords, secants, and tangents and what happens when they interact. In Part 1, we looked at the measure of the angles formed by these things interacting with each other. This time we're going to look at the segment lengths that are formed and how these divide each other proportionally. So we will start off with the example of two chords intersecting inside the circle. The two chords create four different parts. You have part A and part B making up one chord, part C and part D making up another. Now, A appears to be the longest piece and B appears to be the shortest. C and D appear to be really close to each other, but they are all four different lengths. We're going to look at how are they related. So the first thing I'm going to do is I'm going to create some triangles. I created the triangles by adding two dotted line chords into this picture. And what we're going to do is think about level 1 from second semester and how these triangles are similar. They share a vertical angle, so that's one angle. And then if we look at this angle right here, it opens up to this arc. Well, this angle right here opens up to this arc. And from chapter 12, section 3 about inscribed angles, we learned that if two inscribed angles open to the same arc, they are congruent. The vertical angles are congruent. The inscribed angles are congruent. So, due to this, these triangles are similar by angle-angle similarity. Triangles that are similar are proportional. Now, we're not going to write the proportion every time. We are strictly using the proportion to create our relationships. For example, side length A is touching this inscribed angle and this vertical angle. Well, that would actually match side length C. So I can say that A is to C. A is to C as D is to B, from the big triangle to the small triangle, big triangle, small triangle. Just make sure you understand that A is related to C because it is between the vertical angle and the inscribed angle. Now, this is the proportion. We will not write proportions. Rather, we're going to cross multiply it right now and discover the relationship that we wanted. If I cross multiply this, I end up getting A times B is guaranteed to be equal to C times D. This is the two chord relationship. Part times part equals part times part. A times B. If you multiply the parts the chord is cut into, it will equal to the multiplication of the parts the other chord is cut into. A times B equals C times D. This is the two chord relationship. Okay? So, we're going to move on from two chords and start looking at two secants and looking at secants and tangents. Here are two secants. Now, this case is a little tougher to see the triangles, but it's going to be the exact same idea. So I'm going to move quickly. Here are two dotted lines, and due to the exterior angle, so this angle they share, here's one triangle, here's the other triangle. They share this angle, and these two angles right here, this angle here, opens up to this arc, and so does this little angle. So here these two angles are congruent, and now we have angle-angle similarity. So if we have angle-angle similarity, we just need to compare the corresponding sides. So X corresponds to W. This little side length here is across from this angle, across from that angle. So X will be compared to W. But then what is the other side in the triangle with X? It's not X plus Y. It's this length, W plus Z. That's in the triangle with X. So X will be to W as W to Z is related to XY. So X is to W the same way W plus Z is related to X plus Y. Make sure you understand W plus Z is in the triangle with X and X plus Y is in the triangle with W. So these are the same triangle. These are the same triangle. X is to W as W plus Z is to X plus Y. Cross multiply and we have the relationship we are looking for. X times the sum of X plus Y equals W times the sum of W plus Z. I like to say it as X, which stands for the exterior part or the outside, and you multiply that by the whole thing. Most common mistake is people will multiply the exterior times the interior. It does not say that. It says the exterior times the sum of the two parts. X times X plus Y equals W times W plus Z. Exterior times the whole thing equals exterior times the whole secant. This is the relationship for two secants. We have one more. We have a secant intersecting with a tangent. So I've called the tangent T, so remember that it's tangent. And I used the X and Y from the previous slide, X being the exterior part. I will still draw in the two triangles drawn from the tangent point. The hard part about this one is many of you right now probably see three triangles. One of the triangles has X, T, and a dotted line. The other triangle I want you to look at is the large triangle, T and X plus Y and a dotted line. They do share this angle here. And then we have an inscribed angle here that opens up to this arc, and we have a little inscribed angle right here that opens up to this arc. So this angle right here is congruent to that angle down here. That creates angle-angle similarity again. So we have a proportion. Well, across from this inscribed angle is X. Across from the matching inscribed angle is T. So I can say X is to T. And then across from the big obtuse angle is T in the small triangle. And across from the big obtuse angle would be X plus Y. So I can claim X from the small triangle is like T from the large triangle. And T from the small triangle is like X plus Y from the large. So X compares to T like T compares to X plus Y. Cross multiply, and we have our relationship. T squared is equal to X times X plus Y. Or tangent squared equals the exterior times the whole secant. So if we had numbers that we could plug into this, we would have a tangent number. For example, maybe T would be equal to say 10. And 10 squared would be 100. Then we would have numbers inside here. For example, maybe X is equal to 5 and Y is equal to 15. The whole thing would be 5 plus 15, which is 20. 5 times 20 is 100. 10 squared, 100. So I could say T is 10, X is 5, Y is 15, and that would be an example of how we just plug the numbers. 10 squared equals 5 times 5 plus 15. Tangent squared equals the exterior times the whole thing. We will start to look at examples of this in class where we start plugging the numbers in, but for now, those are the three relationships: two chords, two secants, and secant tangent. If you're wondering, what about two tangents? Remember that we have already studied that, and that if two tangents intersect, we know that if one is length 10, the other is length 10. We already knew that relationship. That's it for Chapter 12, Section 4, Part 2. And this was the final video for Chapter 12, or Level 5.